All right, so we've looked at simplifying trig expressions by factoring. Now we're going to look at simplifying by expanding. So expanding, right, is the reverse process of factoring, where we want to condense something, we want to expand it out by multiplying everything out. So we're going to multiply out. All right, so I want to simplify this expression: secant x plus 1 times secant x minus 1 divided by sine squared x. So I have these two binomials in the numerator I can multiply out or expand. So I'm going to do just that. So this is going to be, when I FOIL everything out and multiply it out, I'm going to get secant squared x, secant times secant is secant squared x, minus secant x plus secant x minus 1, right? So I just did first, outer, inner, and last. All right, and then all that's going to be divided by sine squared x. So now I can cancel these secant x terms. So this is going to reduce to secant squared x minus 1 all over sine squared x. And when you're doing these problems, you should always keep in mind if you have an identity that you can use. So secant squared x minus 1, well, we know that we have an identity involving secant squared x, right? We know that 1 plus tangent squared x equals secant squared x. So if I think about that, I can replace secant squared with 1 plus tangent squared. So this is going to be 1 plus tangent squared x, and then I have my minus 1 all over sine squared x. And then now I can cancel these ones. So I'm going to just get tangent squared x over sine squared x. And then now we know that tangent is just sine over cosine. And so I'm going to actually write this a different way. I'm going to write this as tangent squared x over 1, and then times 1 over sine squared x, right? Because we know that dividing by something is the same thing as multiplying by the reciprocal. So dividing by sine squared is the same as multiplying by the reciprocal of sine squared, right? Now tangent we know is sine over cosine, so I'm going to go ahead and just rewrite this first term as sine squared of x over cosine squared of x. And then I have times 1 over sine squared x. And then, ooh, I like that, right? I have my sine squared x I can cancel out. So I'm going to get 1 over cosine squared x. And then we know that 1 over cosine is secant, so 1 over cosine squared is just secant squared. So that complicated expression that we started with cleaned up pretty nicely. All right, last example, we're going to look at simplifying by combining fractions and using identities. So we're going to simplify this expression here. Now we have two fractions, but they gave us some pointers. The first thing we want to do is try to get a common denominator. And then later on in the process, we're going to use Pythagorean identity at some point. All right, so first we need to get a common denominator in order to combine these fractions. So I need to figure out what is the least common denominator between these two fractions. So they just need to have the same thing on the denominators, right? So I noticed that this needs 1 minus sine x needs a cosine, and then this cosine needs a 1 minus sine. So my LCD is just going to be the product of the two denominators, right? So it's going to be cosine of x times 1 minus sine of x. All right, that's my LCD. So what I'm going to do is I'm going to start by modifying each fraction so that it has the LCD. So this is going to be equal to cosine of x over 1 minus sine of x. So to modify that, I need to multiply top and bottom by cosine of x. And then for my second fraction, sine of x over cosine x, I need to multiply top and bottom by 1 minus sine of x. All right, so now I'm going to simplify. So my first fraction is going to be cosine squared x over cosine x times 1 minus sine x. And then for my second fraction, I'm going to take my sine and then distribute it. So I'm going to get sine x minus sine squared x over the LCD. All right, so now they have the same denominators, so I can combine the numerators. So I'm going to go ahead and subtract these numerators. Now notice when I subtract, I need to distribute this negative to both of these terms here. So I'm going to get cosine squared x minus sine x and then plus sine squared x all over the LCD. All right, now, so we've gotten the common denominators, but then they told us that we're going to use a Pythagorean identity at some point. So looking at my expression, do you notice anything that looks Pythagorean? Well, hopefully you notice that there's a cosine squared and a sine squared. And usually whenever we have squared trig terms, that is a dead giveaway that's going to be a Pythagorean identity, all right? So we know that sine squared x plus cosine squared x equals 1. And we have a sine squared x and a positive cosine squared x. So what I'm going to do is I'm going to rearrange my terms in the numerator like so. I'm going to say sine squared x plus cosine squared x. I'm going to leave the minus sign hanging out over my LCD. And I can do that because with addition, order does not matter. Addition is commutative. All right, so now I can replace this entire expression here with the Pythagorean identity, right? This is just going to be 1. So this is going to be 1 minus sine of x, and then all over my LCD. And then, y'all, this cleans up really nicely because now I have a 1 minus sine and a 1 minus sine. I can divide those out. So this is going to reduce to 1 over cosine x. And we know 1 over cosine is just going to be secant x. So with a little bit of algebra and some trig identities, we actually were able to simplify this to one expression.